two or more workers will be working together to give the product output. So definitely the workers' labor's cost also will be added with the product. For example, I am going to take 100 product in a day. There are n number of workers. Then whatever the salary I am going to provide to the n number of workers, that will be uniformly distributed over all 100 product. Definitely the cost of the product will be more. Now here, when you go for the fixed automation, that means the automated transfer lines we are going to use in between the two workstations. Definitely the cost will be reduced, the cost of the labor will be reduced. Then the cost of all these equipments along with the dead cost and the material cost along with the manufacturing lead cost, and all these will be spread over the entire whatever the product we are going to take per a particular shift. So definitely the cost of the product will be reduced. So it is the justification for low product cost and high production rate. One nature of this fixed automation is that high production rate. The rate of production will be more because all these the elements which are included in this. For example, you say robot, the work holding devices, the transfer mechanisms, the work which will be positioning on the machine, all these will be fixed for this particular part only. Definitely the production rate will be very high, and minimum work in progress and manufacturing lead time, because all these will be integrated together. You know that the manufacturing lead time is the amount of time which the part or a product is spending since from the raw material to the final shape. So definitely it is automated flow line, and automatically the material will be transferring from one station to the other station. Then definitely there will not be any hindrance for the stoppage of the material in between. Definitely the manufacturing lead time will be better. It will be lesser. It should not be more. It should be less. And minimal work in progress. Minimal work in progress in the sense the part it will be taking the shape at particular machine will be reduced, and minimal use of factory floor space, because as in the beginning only the main idea behind going for the integration and is that the multiple operations on a single station and the simultaneous operations on a single station. Very two important terms. The simultaneous operations in the sense while the work is doing, the particular operation will be doing, parallelly other operation will be done on the same station. That means a single workstation will be doing two or more workstation works. So the amount of the space which is required, the two different machines will be reduced, and parallel operations and the multiple operations. If you do, definitely the factory's floor space will be reduced. How the fundamentals of automated flow lines? What are the fundamentals of automated flow lines? I'll be taking a simple example of this. It is one single workstation, one single flow line, not workstation. There may be parallel workstations. The two or more workstations will be working together. For example, a very simple example, please look here. Try to give the attention. This particular workstation have a time sequence of 1 minute. It will be taking a time sequence of 1 minute. And this will be taking a time sequence of 2 minutes, for example. So that means this the part which will be processed in this particular workstation will be taking 1 minute. The part which will be taking or which will be processed in this workstation will be 2 minutes. So definitely the production, the cycle rate of production rate will be more in this, double in this, and it will be lesser, 0.5 times. So here we can have two parallel workstations of the same kind, so that the work will be transferred to the two machines here. So definitely the line balancing will be done. The meaning of line balancing is that to avoid the blocking of station and the starving of station. Because you can see that in this particular workstation, it takes 1 minute and it will be taking 0.5 minute to process, and definitely it required more. it required more and it is providing less. Here we can provide the two parallel machines so that it will be line will be balanced. And what are the nature, the fundamentals of automated flow line? The fundamentals of automated flow line is that the work will be flowing from left to the right, and the symbolically I have represented something here. Please look here. These are the parts. These are the parts. If I put here cross mark, it will be showing if I put a cross mark in this, it will be showing the part is progressing on the workstation, and the part will be moving from here automatically onto the conveyor, and it will be processed here, and in between any testing is required. It may be a manual testing or automated testing, and if a manual intrusion is there in the line, manually we are going to upload the material or do the testing, that the line will be called as partially automated flow line, because manual intrusion is there. So definitely it is part of the work will be done by the manual and part of the work will be done by the automated systems. And there may be n number of workstations. You can see that station 1, station 2, station 3 and station n-2, n-1, n. Okay, so many n number of stations will be there, and at each PROC auto, that is processing automation on the workstation, and on each workstation we may have to do a single operation or multiple operations or parallel operations. As the principle says, principally here the two parallel operations can be done. Okay, and two simultaneous operations can be done on the processing automation workstations. Okay, this is what the nature of the workstation. Here what I have given, an automated production line consists of multiple workstations that are automated and linked together by work handling systems that transfer the part from one station to the other station. The raw work part enters one end of the line, that means from left to the right. The line may include inspection station to perform immediate quality checking. And here another one important thing is that the testing in process, on process. In process, there are two types of testing. One is inline testing and offline testing. Offline testing is that the part will be removed. The part will be removed from the conveyor. The testing will be done. Again, it will be uploaded onto the transfer systems. That is be offline testing. The offline testing, what happened? The nature of the offline testing is that for certain time the production will be stopped. The conveyor movement will be stopped unless the testing will be done. The thoroughly testing will be done manually. The part will not move to the next station. And in some of the cases, the testing online in process, online off process. Online in process is this nature we can find in the CNC machines. Any errors incurred or the dimensional errors are there or any changes to be done, those changes will be done automatically within the machine itself. It will be having well built-in testing systems. So that time the rejections will be very, very lesser. In some of the cases, once the total complete work is done, then we are going to do the testing. Then manually, if any rejections are the rejected part will be removed from the conveyor and the right parts will be sent on the conveyor. Okay, this is what the automated flow line. Okay, automated flow line. Once again, I'll be explaining the terms, repeating the terms. Buffer storage unit. Here I'll be explaining this particular station is producing the parts at high rate and this is producing at low rate. So definitely, as I told you in the beginning, the blocking of station and starving of station will happen. So one case. The second case, even though the cycle time for all these workstations are same, in between them the buffer storage unit will be provided. The main purpose of providing the buffer storage unit in between the two lines is that whenever a particular machine has come for the maintenance, then the stored unit will be supplied. For example, you say this particular machine has come for the maintenance. The station 2 has come for the maintenance. Now, due to this, the entire flow line will be stopped because it is integrated. So to avoid the stoppage of this integrated flow line, in between them, we are going to provide a buffer storage unit. The buffer storage unit already we have provided. This already some parts which are produced earlier, those have been stored here. Now once it has come for the maintenance, the part from the storage unit will be taken to the station 2 and the work will be progressed. So the main purpose of providing the buffer storage unit is that in between them, the storage unit will be storing the partly completed part from the previous station, and whenever it is required or the cycle time variation, that time the buffer storage unit will be providing the material. And buffer storage unit is not just a simple manual dumping. It is not simple manual dumping. It is automatically storing the parts. And whenever the parts are required, those parts will be retrieved from the buffer storage. It is also automated. So all these together, the transfer line, automating the workstations, automating the work holding devices, automating the part holding devices, and the robot, all this will be configured for a particular product only. So, hence the name indicate it is called a fixed automation. In this, due to all these, what happens? The cost, the initial cost, the high investment will be there. The cost of the system, the automated line will be more. In the beginning, one time asset it is, but later on the labor cost will be reduced. Definitely the cost of the labor will be reduced. So many labors will be eliminated in between the flow lines. The main idea behind going for the automation is to not to make the workers idle or not to make the workers jobless, unemployed. It is not that. The quality of the product will be increased. The quantity, the demand can be supplied. Okay, and the workers here we are going to do assigned a particular job. Therein, the same workers can be provided the white collar job at the same industry. So definitely the high demands can be, the demand can be supplied and a stable product can be taken, and wherever we require to have the similar kind of the product for longer time, then this is more suitable. And whenever we want to have multiple operations, some kind of work holding devices, part holding devices like jigs and pictures, those will be specifically made for this product, so that the quantity of the product will be increased. Definitely the cost of the product will be decreased, because the entire cost of the industry will be distributed over the products. Definitely the cost will be reduced. And other one, what are the benefits? Already I told you the benefits will be low amount of direct labors. The labors involvement will be very less. So definitely the cost of the product will be very less. And low cost of the product, as I told you, the cost of the product will be the entire investment, inventory on the totally entire industry will be distributed all over product. So definitely the cost of the product will be reduced, and minimum work in progress and minimum manufacturing lead time, and the minimum usage of the factory usage. Okay, factory the spore flesh can be reduced. This is what I wanted to explain today. I think it is more than enough today. And let me have a discussion. Kindly be open, make a discussion. Please ask me any doubts are there.